Hiya, Chaz.
Hello, Lyndsey.
Yeah.
How are you?
Yeah, I'm good, thank you. I hear you've had quite a challenge recently.
Yes, we have. As being part of the applications team, we were challenged to come up with a component. Let me show you where it is.
Yeah, I know you're an engineer, so you like a challenge.
Absolutely. We were challenged with making a screwdriver.
Oh, okay.
And not a simple one.
No,
because that would be just too easy.
Yes.
So we decided to make a ratchet screwdriver.
Okay.
Yeah, out of various materials, considering things like weight, durability, and ergonomic design as well.
Yeah.
So
I bet you came up with some challenges though, because
yeah,
none of this sounds easy. By the way,
none of it's easy, because as you can see from the design and the model, we had to make sure that all the parts fitted correctly to the right tolerance, and the mechanism that we used to create the ratchet, that had to work flawlessly.
Yeah.
So you can see each of these levers moving backwards and forwards, and making sure that the cog on the spindle would be moving correctly, and the mechanism, how it locks. So you can see that the angle is absolutely perfect.
This is probably one of the most precision-made screwdrivers this planet has ever seen. Oh my gosh, you're working to microns here.
Yeah.
But forgive me, but you know how you've designed this in SolidWorks?
Yeah.
Do you, before you cut any metal, you're proving it out? All of the movements are out before any metal gets...
Absolutely, you have to. Otherwise you're just cutting metal for the sake of cutting metal, not making sure it works. By doing it this method, we're 100% guaranteeing any movement in the mechanism will have clearance where it's needed, and also that the mechanism works correctly. This is the first step of the process, the design side, making sure everything works. But let's go and see the actual part on the machine.
Okay.
So Lyndsey, let me show you some parts that we've laid out earlier.
Oh wow!
We've got the handle, the final iteration of the handle. This is the spindle, and then we've got the actual mechanism there as well.
Oh, it's so good to see it in person.
Yeah. So this was the original design. We came up with a 3D printed version to test out all the parts and the mechanics. We then moved on to the actual handle itself, which is a lot more ergonomic. Yes,
it kind of looks a little bit sexier as well, more aesthetically pleasing than...
I'm glad you've said that.
Yeah. I'm allowed to, it's fine.
So then now this is the actual spindle, and the design iterations that we had to make were, we had to put bearings on either side to make sure that when the user is engaging the screwdriver, that it wasn't biting into the aluminium.
Oh yes.
Otherwise it would just become a very, very sloppy fit.
Yeah.
And from there, it then fits into the actual mechanism itself.
Look, oh
and
my
that's
goodness.
the whole mechanism and assembly in
the way you just did that was just perfection. It just dropped into, but that is, the type of accuracy and the tolerances that you're cutting.
That's what we had to do. It wouldn't have worked any other way.
You're kind of showing off what you're able to do here as like showing off your skills.
I'm not enough. Yeah,
yes,
okay,
yes, you
I will, I'll say it.
You'll take that, you do it, you're being very humble. I like it.
So,
and I like the fact that you've explained some of the problems that you came up against. Were there any other problems because you're talking about the materials as well?
Yeah, the materials, for example, the cap has now got these two lugs on it.
Okay.
To keep the plate in position.
Oh, I see. So these go into, yes, they go onto there.
That's correct. So the plate goes onto the top, locates everything in position. He says, there we go.
There we go.
And basically holds everything in place. Right. So the final piece is the aperture at the back where you can put all the drill bits in.
Yes. Oh, I see.
And that locates on.
It looks like a watch, and that feels really nice as you spin it. It's like a grip as well.
Absolutely, yeah. So it was intended to look like a well-known brand.
Yes, a watch band. Yes.
And I think the finish has come out really well.
It looks really good, and it's got that a double purpose because it spins round.
It grips onto.
Yes.
You can grip onto it. So, with all the parts assembled now, we need to go and have a look how they're made on the machines.
Yeah.
Lyndsey, we're coming over to the machine where the handle was manufactured.
This is a fixed head.
Yes, this is the fixed head twin spindle twin turret, and we made the handle on this machine. And basically produced all the parts, the features on the internal on the sub. So we made the drill bit side on the main spindle and all the internal features of the mechanism.
The mechanism, that's really intricate in there as well, isn't it?
Yes, it is, yeah. So all the small parts on the machines were made on, some on the SL, some on the SB16, purely because they were small parts and we were picking up what they call prismatic parts, because they weren't turned. There was no turning on those parts at all.
Yes.
So we had to make a collet, design a collet, manufacture the collet, put it on the machine, make the part, pick the part up, and also on this machine, this is the machine that created the spindle and the end cap, which looks like
the clock.
A clock face.
I love how you've engraved the star into there as well.
Well, we have to leave our mark, don't we?
You absolutely do. And your name's on that one as well.
Absolutely, yeah. So the one that's got your name on it is back in the office.
Fantastic. Just a quick question on this. Is it tricky? Because that's quite a long component there.
It is a long component, and being 316 caused some swarfing issues. So using the technology on our machine, SCP, we use that to basically chip the swarf and still create this surface finish that was being run on the bearings.
How do you feel when you've made something like this, and are you waiting for someone's reaction when you give it to them? Or?
I see the reaction straight away, and it's like, can I have one? Because that's how people react. As soon as you make something, can I have one? So over the years, I've produced many parts, many giveaways for Star, and hopefully continue to do it.
Absolutely. I think you and your team should be really proud of this. It's just all the thought. Do you think people fully appreciate all the time and the thought and the effort that go into it? Because you obviously see that final component, but there's so many iterations that you've gone through.
People don't see the heartache in this when we're making these kind of parts. There's lots of design tweaks that we have to do to make it work successfully. And it's only once we're happy with it that we can actually say, yes, we pulled it off.
Yeah, absolutely. Thank you for taking me on a tour here. And you can really tell how passionate you are about this.
I love making these bits. It's the perks of my job. But just wait till you see the next one.
Yes.